In this video series, we are going to show you how the Chowla's conjecture implies the Sarnak's conjecture. But before we introduce the statements of those two conjectures, let me first give you some definitions. The first definition is about the topological entropy of a bounded sequence. Let F be a bounded sequence of complex numbers. We say F has topological entropy sigma if sigma is the least non-negative number or infimum such that for any epsilon greater than 0, the sequence of vectors, so we are going to look at this sequence. Each member in the sequence has m components, f of n plus 1 all the way through f of n plus m. This is a sequence of vectors in Cm, such that for any epsilon greater than 0, the sequence of vectors can be covered by this many balls, by big O, the exponential function of sigma times m plus little o, balls of radius epsilon under the L infinity metric as m goes to infinity. Now maybe some of you don't remember the meanings of big O, little o. Now let me help you to recall them. Recall in calculus that alpha of m and beta of m be two functions with beta of m non-negative for any m natural number. Then we say alpha of m is big O of beta of m if there's a constant c greater than 0, such that the absolute value of alpha of m is bounded by a constant, this constant c, times beta of m for sufficiently large m. And we say alpha of m is little omega of beta of m if you look at this quotient, alpha of m divided by beta of m, this limit as m goes to infinity is 0. However, in this definition, the c is not necessarily an absolute constant. So what does the implied constants here depend on? We should clarify this. So let me add a remark here. The implied constants could depend on this function, this sequence f, as well as this epsilon greater than 0, but not on this sigma. So implied constants here will not depend on sigma. So that's the definition for the topological entropy of a bounded sequence. I know the statement here may be a little bit hard to understand because this is not a specific number of balls. It only tells you what asymptotically this number of balls covering the sequence is. but we will soon show you an example to help you understand this.